Hello everyone, welcome back to our channel. Today we are back with a very interesting string problem from the blind 75 SD sheet. That the name of the problem is the palindromic substring. So let's see the problem statement. So we have been given a string S. We need to find out how many of its substring are its palindromes. So I hope you guys are aware of what are palindromes. If not, I will tell you here. So basically the palindrome is a string that reads the same forward and backward. Okay. And a substring is a contiguous sequence of characters within a string. We need both the things. We need the knowledge of both the things in this question. Like we need first what the question is saying. Basically, we need to find out how many of its substrings are palindrome. So palindrome is clear, that reads basically a string that reads the same forward and backward, and a substring is a contiguous sequence of characters within a string. Okay, let's see the examples that we fetch from the lead code website. So basically examples we have given as input string s is equals to abc and output we are getting as 3. How 3? Let's see. The palindromic substrings in abc are a itself and b and c. So we can say the individual characters are also the palindromes of itself. So we are counting it here. Similarly, in example 2, we have A. So this time we have palindromes, number of palindromes as a substring as 6. How 6? Let's see. Explanation part is basically the palindromic substrings are basically individual A, then in pairs A, and A. Similarly, all these are counting to 6. So that's coming the output here. So first of all, I have explained and key terms are palindrome and substring. So palindrome you guys already know, and substring is basically in example madam or race car or ABB. The substring is basically the continuous portion of the given string. For example, for ABC, the possible substrings are, as I told you above, ABC, AB, BC, ABC. Okay. So the brute force approach is very obvious. Like we will generate all the substrings, then out of that we will find out which are forming the palindrome, which are the palindromic ones. That is the basic way to solve this problem. So we will after generating all possible substrings, we will check if each substring is a palindrome, and we will count the total number of palindrome substrings. Okay, it's that simple. But yeah, this approach sounds very simple, but let's analyze its complexity first. Like time complexity for generating all the substrings will take the use of 2 nested loops, starting and ending indices. So each substring is then checked for being a palindrome. So it will be like 3 loops. This will result in an O of n cube time complexity. O of n square is for substring and O of n for palindrome check, which will make out around O of n cube time complexity. So the approach will be like very slow for the large inputs if we consider n is equals to 1000. And space complexity, we don't need to worry of it because it will be constant only, since we only use a few extra variables. And it is but obvious if we are taking like O of n cube approach, this is not an optimal one. So we need to think something better, right? We need to think something optimized version of it. So we will move towards the optimal approach, how we can do it basically. So I will show you how we will solve this problem. Optimal approach is quite different from other techniques, but yeah, it's very efficient. So we will expand around the center. Do not worry about this thing. I will tell you very briefly, very simpler, by breaking down into the steps. I will tell you all how we will do it. Basically the idea is we will take each character, and each pair of adjacent characters in the string can be considered as a potential center of a palindrome. Okay. So suppose we will expand outward from each center, checking for the palindromes. If the characters at the both ends are equal, we will expand further. After that, we will stop when we find a mismatch in the characters. This method will ensure that we will count all the palindromic substrings efficiently. So I guess like many of you doesn't able to do it with this idea, just the idea. I will definitely tell you the dry run of it, how the flow is going, how the approach is running. So do not worry of it like how you are not getting it. I will tell you. Please be there till the end of the video. You all will get the solution. Okay. So basically, obviously, the much better than the brute force solution. Now I will dry run for you for better understanding. So a string is basically we will consider A B B A. Okay. So step 1 is basically considering each characters as a center. So even first character, from the first character only we will start considering it as a center. So every character in the string can be a center for an odd length palindrome like ABA. So how it is a odd length? It is containing 3 letters. So it is odd length palindrome. So what it is saying, every character in the string can be center for odd length palindrome, and every pair of adjacent characters can be a center for even length palindrome. Okay, like ABBA. So far a string of length n, we have n single character centers, odd length palindromes, and n minus 1 adjacent characters centers for even length palindromes. So we will now expand step by step. Iteration 1, like obviously we are considering this example ABBA. Okay, so how it is basically working, things are working. So iteration 1, at center at index 0, we are taking the center at index 0, that is A, character is A. Okay, and expanding it outward. Okay, so in if we consider expanding it outward, that means the end of it. So A is expanding, if we expand outward, that is A only, so it will be palindrome. Now we will not expand further since the next character is B, that is not equals to A. Okay, so we will count so far, that is 1, and we will stop the iteration and we will move to the next iteration from the left end. Okay, now the center comes at index 1, so the character will be B this time, and if we expand outward, we will, so B is a palindrome for itself, and expanding out, if we expand outward, that is the second last. So second last will be like BB, that is also a palindrome. So after that we will expand further, ABBA, this time this is also a palindrome. So we will be considering B, BB and ABBA. In this character we are getting all the substrings as palindrome. So counting will be so far 1 plus 3, that is 4. Okay. So now at iteration 3, we can see center at index 2, 0, 1, 2, that will be B only. Okay, so the character is B, and if we expand outward this time, expanding the outward part, we will get the BB as output, but we have already counted in the previous step. So counted so far, that will be 4 plus 2, 6. Okay, we are obviously we will add it in the counting. So next at iteration 4, center this time at index 3, and at index 3, 0, 1, 2, 3, that is A. Okay, so single character A. So if we expand outward, A will be A only, so it will be palindrome, and it's the last element, so we cannot expand it further. So the counting so far will be 6 plus 1, that is 7. At iteration 5, the center will be at index 0, 1, that is AB. This time even length center we are taking, and AB is not a palindrome since we cannot expand it, so no new palindromes found. So this time why we have taken AB, because it is a even length, so we are taking adjacent character also. So counting remains 7 only. At iteration 6, center will be at index 1, 2. So BB is an even length character, so expanding outward, BB is palindrome, and expanding further, if we expand, so A will be there, that will be obviously ABBA will be the count. So count will be get added, 7 plus 2, that is 9. At iteration 7, we can see that center and index 2, 3. So BA even length character, but BA is not a palindrome, we can see from the string. So no new palindromes found, final count remains 9. So these are the final answer. Time complexity for this approach, we can see that we are expanding around each center, taking every character as center step by step after every iteration. So taking at most of n time per center. Okay, since there are 2n minus 1 centers, So the total complexity will be like O of n square. Okay, because in even length we are taking it 2 characters at a time. So the total complexity will become O of n square, and space complexity, like we are using only a few extra variables, so the space complexity remains O of 1. Now let's discuss the code part, how we are doing it. Basically this is the function to count the number of palindromic substrings. This is the function which will be given to you on lead code. So this is this in n is equals to string dot size is for the length of the string. We are initiating count is equals to 0 for storing the number of palindromic substring. Now we are using one very interesting thing here, like we are using helper lambda function to expand around center. Okay, so lambda function we are using, that is expand around center, is for int left and right, and we are expanding as long as the characters match, like we were, as I told you all in the dry run itself. Okay, so we are using the while loop, and we are writing the condition as if while left is greater than equal to 0 and right is less than n, for basically avoiding the out of bound situations. This we have done, and string of left equal to string of right. Basically the three conditions are there. Left should be greater than equal to 0, that is it should start from index 0 and it should end at the last index. And one more important condition is this, that is we have to match the string characters. As when the string of left becomes mismatched with the string of right, we will definitely not be going inside the loop. So as till the time it is the while loop is running, we will increase the counter, because we are found get if it's obvious that if while loop is encountered, basically it is following the conditions and we found a palindrome, we will increase the count of it. Okay, and we will decrement the left pointer outward. Basically we will move the left pointer outward, and we will move the right pointer outward, that is plus. Okay, after getting out of the while loop, we will iterate over each character to consider it as a center. Okay, basically for loop, simple for loop, and we will take the for the both conditions, like for odd length palindrome we are taking like this lambda function, expand around center I comma I, single character center. And for even length palindrome, as I told you in the dry run, we will take 2 character center, that is expanding around center I comma I plus 1. And after that we will return the count, that is the total count of the palindromic substrings. So if I give you a summary of this code, is basically what we did. We are iterating through each character in the string. We are treating each character as a potential center for odd length palindromes, that is single character, and we are treating each adjacent pair of characters as a potential center for even length palindromes. Okay, so expanding around center function, like this is the lambda function, and expand, we have, this is very key point here, like we have to expand outward while the characters at left and right matches, and if it doesn't matches, we have to move ahead with the next iteration, and after that at last each varied expansion increases the count. Okay, and we have to return the count of it. Hope so you all get the solution. If you get the solution, and if you have any doubts, you can put it into the comment section. Till then, thank you.